Stage 1, Stage 2, pressing for flight.
It's recording the whole thing.
Awesome. So I can record our voices.
Guys, 35. Let's count down at 30.
Okay.
No, 10.
T-minus 30 seconds.
Okay, 10. 20.
10. We're not even at 20. 10.
T-minus 20 seconds.
Falcon 9 is configured at flight pressures.
T-minus 15.
10.
T-minus 10.
9.
9.
8.
8.
7.
6.
5.
4. 3.
2. 1.
0.
Materials engineer, and I'm going to walk you through some of what you're seeing and hearing as the vehicle continues to ascend. You can tell that we've had a successful liftoff initially. The Falcon 9 has cleared the towers and is rapidly approaching what's called maximum aerodynamic pressure. This is known as max Q. It's when the rocket is pushing hardest against the
Speed
atmosphere.
550 meters
hear
per
the
second. Distance 200 kilometers.
You can see the engine
Stage 1 propulsion is nominal.
The engine plume widening as the rocket is increasing in altitude and there's less pressure.
The camera's on board. I'm waiting to see that.
Temperature power still filthy.
Hold it in.
MVAC has begun chill.
MVAC chill means that the second stage engine is preparing itself to ignite. Shortly after main engine cutoff, we're going to separate the stages and begin the second stage ignition.
T-plus 2 minutes. Speed 1.2 kilometers per second. Downrange distance 11 miles.
Quiet! Don't ruin this for me.
Main engine cutoff approaching shortly.
Mallory! What? Stop! Don't you ruin this.
Returning to land as the second stage powers the Orbcomm satellite to low Earth orbit.
Here comes the
Stage 1 is on its foot.
I thought this whole thing was a good part. I know. Isn't even going that fast.
The fairings have successfully deployed. You can hear everyone is phenomenally excited here. The Merlin vacuum engine is burning bright as it's moving up to speeds approaching 8 kilometers per second. The first stage will soon begin its series of 3 burns to head back towards Cape Canaveral. First, it will reorient itself.
Alright, now we get to see this thing.
It will reorient itself using cold gas thrusters. It'll go perform 3 more burns as it approaches landing zone 1.
Yeah, this part's going into space, but the other one is waiting.
Where's that going? Freaking 5 7.
Stage 1 boost back is starting.
5 times. 6 times.
The boost back is the primary burn that will get the vehicle moving more slowly
Propulsion is nominal.
and heading back to Cape Canaveral.
Capture acquisition of signal.
Guys, please don't mess this up for me. Alright. You guys can.
Man, that is awesome. We are well on our way to taking Orbcomm to orbit, and that boost back burn, that's the first step of a really intense process to get that stage 1 back on land. Yeah, like so many things just happened. My heart beat twice. It took 2 beats since we were on last, first of all. Secondly, there were so many important things. There was first the takeoff, the immediate takeoff, which is just a huge relief. Then there's max Q, and you have the maximum pressure. Past that, huge relief. Then the stage separation, and everyone here went nuts because that people are going crazy. And then the boost back. So everything is so far looking great, right? So far, so good. Yeah, that boost back burn is going to go on for about 30 seconds, and then it's going to cut off. We're going to flip the stage back around, and as we enter that atmosphere, those great fins are going to pop out and start the guidance in through the atmosphere. And so we're about 4 minutes away from when it would touch down, right? Exactly. Yes, about 4 minutes away.
Everyone's really excited.
A lot of energy.
Awesome. So much energy. Yeah, that boost back burn is really important because it reorients us back down to the launch site, back down to landing zone 1, as opposed to normally after the first stage separates from a rocket, after the second stage separates from a rocket, that first stage will continue on a sort of ballistic trajectory and into the ocean, but we are coming back to land.
One of the things I think that is another thing that is not that intuitive is what an orbit is. And so right now, the second stage is going right into orbit. Right. Yeah, it is going faster and faster and higher to try to ping these satellites off into orbit. And what that means is you're not floating in orbit. The gravity is almost the same as it is on Earth. So what's happening is it's almost like the second stage is like a giant throwing the satellites as hard as it can, so that they're going 17,000 miles an hour. So you can basically curve around the Earth. They're falling, but they're going so fast that they're actually curving at the same curvature of the Earth.
Well, yeah, and I know the same thing. A lot of people that I think of space as just going up really high and back down, which is a lot of like space tourism kind of things. But what we're trying to do is we're trying to deliver satellites and stuff like that.
They're super fast sideways,
which is why it's really hard to bring the stage back, because the faster you go, the harder it gets to actually come back as well.
Yes. So, and also, being able to get all of these satellites into that orbit, that's really hard. But then having 11 and getting them to maintain their orbit is also really difficult.
But let's check in actually with John Isbrucker for another update on how both the second stage burn is going and also how that first stage is looking too.
We're at T plus 7 minutes, 30 seconds. Everything continues to go nominal, as we like to say here at SpaceX. Falcon 9 continues to power its way into orbit. The second stage is building up to 4.7 Gs of acceleration. Now currently we're about 2 minutes away from shutdown of the second stage engine to get into orbit. Engine performance continues to be nominal. I'm looking at the trajectory. We're going right down the middle of the track. That's good news. We're right where we want to be. For the first stage, you heard about the first boost back burn. Coming up in another minute or so, or coming up very shortly, is the entry burn, and then hopefully the landing burn. And you hear the cheering in the background.
Super hard. Not only do we have a series of maneuvers that we need to achieve in order to get that rocket back down to the ground, but it's actually a super complicated thing. Like, you did some cool analogies and cool math to figure this out.
To figure out how hard it really is. And so I crunched the numbers with the size of the rocket and the size and how high it's going. What's happening with the first stage is it's like launching a pencil over the Empire State Building, having it reverse, come back down, and land on a shoebox on the ground in a windstorm. That's
the wind is the critical part.
Yeah, I don't think I could throw a pencil over the Empire State Building and capture it.
Trying to do. And the crazy thing is, we're like 30 seconds away from this
crazy maneuver.
This extremely energetic room is a hush.
Here we go! Here we go!
the most important thing you'll ever watch. No way! Holy! Woohoo! 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 No way! No way! Oh my God! Look at it! Woo! Oh, this is the best day I've ever had. My Christmas has been made. Oh my God! Oh my God! Woo! Woo! This is my Super Bowl, dude. They freaking did it! No way! No freaking way! Unfreaking real. Laying in the background. This is the coolest thing I've ever seen in my entire life. Yesterday. This is about. This is about Neil Armstrong. That's about
jumping
You'll remember this.
It's hard to understand what a big moment this is. Every single space agency in the world is watching this. This is, I mean, there's so many quotes of people in space agencies saying, this will never be done. And 5 or 6 years ago, people saying, it's not possible to land the first stage. And they did it. You guys did it. Nice going. And we just got until we have a successful reorg of the second stage. We're making preparations for the Royal Orbcomm satellite. So we are on a nominal trajectory for the second stage as well.
This is such incredibly an exciting thing. It's important to remember that our primary mission is, in fact, to get those 11 Orbcomm satellites into orbit. There are going to be a series of 6 separation events, and in a moment, you will see the first 2 of the 11 Orbcomm Generation 2 satellites separating from the second stage of the Falcon 9 rocket. We have cameras for at least some of those deployments, and those will be coming along shortly as the mission continues to progress nominally. A couple of quick facts about the Orbcomm satellites. There are 11 of them. There's also a 12th mass simulator, and that's there to just provide balance. Each satellite weighs about 172 kilograms, and it's for a total mass of just over 2,000 kilograms. For reference, that's about the size of a fully grown adult lion. Each satellite, when stowed, is about a meter by half a meter tall. So about yay, and straight down. It's about the size of one of the small refrigerators. But that doesn't mean it's nowhere near that simple. Fully deployed, the satellite actually extends out its arms 13 meters, about the size of a telephone pole. Now the 11 satellites are mated in 3 tiers. There are 4 farthest away, then 3, and then another 4 fairly close to the Merlin vacuum engine. And now the way that we're going to begin deploying them is with the 4 satellites on top, then the 4 satellites in the bottom, and then the 3 satellites in the middle.
First spacecraft.
And
spacecraft.
we have visual confirmation. The satellite deployment. Mission is continuing to progress nominally. We have 5 more satellite separation events. Now, the reason that we're staggering these deployments is in order to allow the satellites to have some spacing, to give them their proper location within the constellation that's going to provide that continuous global coverage that Lauren was speaking about earlier. They have a parking orbit of about between 620 and 660 kilometers in altitude. And we're waiting for confirmation of the next few sets of deployments.
Spacecraft 3 and 4 have been deployed.
You just saw the next 2 satellites deploy. Mission is continuing nominally. You'll notice that you can only see one satellite come off the actual payload fairing, or fairing adapter, forgive me. That's in order to keep the satellite and second stage moving in a straight path.
Up there to put those things in orbit.
If the,
That's okay, there it goes.
Third satellite deployment. As you can hear, everyone here is just extremely, extremely excited that we both have a first stage that is sitting on ground, and also we are taking care of the nominal primary mission here. It's all about delivering those satellites to orbit as well. The secondary, they got the sugar on top, remember? Cherry on top was the first stage. The worst thing that can happen is after this incredible moment, if something goes wrong here, it really would kill the bus. So, really, want to get this right now just to orient me and everyone. So, we've been deployed, correct? Correct.
Yes.
Out of
Well, 3 deployment sequences, 2 satellites per deployment. So 6 have been deployed, which is just over half of them.
and now there's 2 more deployments.
3 more deployments.
3 more deployments?
Yes.
Okay. So for 11 total.
Right.
And you're only seeing about 1 go off at a time because that's given our camera angle. The other has half of that payload fitting. You can see there's another satellite as well. Another successful deployment. Your confirmation that is good. And just remember, that is a live view from space. That is the blackness of space. We are 620 kilometers in space right now.
Nothing is cool. I mean, it looks like it's just sitting there calmly, and these things are coming out, and everything's going slowly. When the fact is, these things are going 17,000 miles an hour. And I kind of figured out once that if you're on the beach and something was going this fast out into the ocean, it would go over the horizon and out of sight in a half a second. And that's how fast these are going.
It's insane. And there's the
Looks like we
4th
just had
deployment. It's another successful deployment.
These people are celebrating.
We're waiting for just the final deployment of the constellation here. Should be about another 20 seconds or so. We'll be seeing that last satellite be separated.
This will be the 11th satellite, and that will complete this mission. After we deploy this final satellite, we will then deorbit the second stage. And we have successful deployment of the 11th and final satellite.
And secondary mission done. Oh, dude.
Is there another satellite? That's it.
All right. And with the successful of these satellites, it is time for us to sign off today. This has been a wildly successful return to flight for SpaceX. A wonderful first flight of our Falcon